Hey guys, our task for today is first of all going to be to finish our flow chart from yesterday. So yesterday we made a flow chart just kind of organizing our 3D solids, and we finished the left side, which covered something called polyhedra, which is just a fancy name for any three-dimensional shapes that are made only of polygons. In other words, they can have no curves to them whatsoever. We said a polyhedra with one base is called a pyramid, and then a polyhedra with two bases is called a prism. And we name both pyramids and prisms by their bases, whatever their base shape is. If it's a triangle, it's a triangular pyramid. If it's a rectangle, it's a rectangular prism, right? So now we're going to finish the right side, which is going to be our 3D solids that are made of circles. So let's do the top one first. There's a shape that is three-dimensional that has one circular base called a cone. So to draw a cone, you can start at the top vertex and draw almost what looks like is going to be a triangle. But instead of connecting the bottom side with a straight segment, you're going to draw an oval for the bottom part. So there's a cone. If you want to make your cone fancy, when you draw this oval, you can make the outer portion solid like this, almost kind of like a party hat. And then on the inside, when you finish the rest of the oval, that can be dashed or dotted to kind of give your two-dimensional shape depth. So there's a cone as a one base. Okay, a 3D solid made of circles that has two bases is a cylinder. Okay, a cylinder is kind of like a prism. That's why it's aligned with it here, except it can't be considered a prism because prisms can't have curves. But a cylinder has two circular bases that are opposite of each other. Okay, so to draw a cylinder, you'll start off with an oval. You'll drop down your two sides like this, which kind of looks like a height. And then again, you can draw, basically you're going to make the same oval on the bottom, try to make it the exact same size. But if you, again, wanted to make it even a little bit fancier, when you draw the oval on the bottom, you'll connect the bottom part, the outside part, with a curve. And then on the inside, your curve will just be dotted to show that there's depth to your cylinder. And then our last three-dimensional shape that is made of circles, doesn't have any bases, is a sphere. Now, drawing a sphere is not complicated, but it is problematic because if you just draw this, it's hard to show that this is not a circle, right? So basically what you can do is to show that this is a sphere is you can draw a oval in the middle of it to show that it has depth, or again, since it's on the inside, if you wanted to make that a dotted oval in the middle, you get something that kind of looks like this for your sphere. Okay, so that's it. Those are all our 5 groups of three-dimensional shapes. We have pyramids and prisms, which are made up of all polygons. And then we have cones, cylinders, and spheres, which involve circles. Okay, today's notes that we're starting from the beginning cover something called nets and cross sections. I hope as you look at this sheet, it at least kind of looks familiar to you. I expect that you've done something like this in younger math classes, even before you got to high school, probably. It's more about, the notes are going to be really easy because it's less about giving definitions and more about you visualizing and conceptualizing the shapes. So let's actually define something though, what these are called. So a net is a two-dimensional picture of a three-dimensional shape. So think about that for a second. Your paper that you're writing on right now is two-dimensional. It's flat. It goes up and down and left and right. Those are the 2 dimensions. Well, up, down is one dimension, left, right's another dimension. In order to try to represent that 3D shape, it's like if you took a box, if you will, you got a package delivered to the house, and you took a box cutter and you cut that box along the edges, you can fold all of the parts of the box down flat. That would be creating a net of that box. Okay, similarly, if you think about these shapes that I have here on the paper, if I gave you some scissors and I told you to cut out the nets, you'd be able to fold them along all of the edges and create three-dimensional shapes. Okay, that's what nets are for. So it can be folded to form the 3D shape. So our job is to figure out, if we were to fold these nets, what 3D shape would it make? Well, the first thing I like to do is classify. Does it have curves or not? Because that tells me which side of my flowchart am I choosing. Well, this first shape here does have curves. It definitely has circles. So I'm looking on the right side of my flowchart. Notice it has two circles. So if it has two circular bases, then my only choice for this one is a cylinder. All right, because it has two circular bases. Okay, the middle one. Again, first thing I want to ask is, does it have curves? The answer is no. So if this doesn't have curves, then this is either going to be a prism or it's going to be a pyramid. Now, you have to be very specific, okay? You need to give me the most specific name possible. So when I'm trying to decide between a prism and a pyramid, if I look at my flowchart, the difference between the two is the number of bases. Pyramids have one base, prisms have two bases. And if you remember yesterday, we said that the bases were typically different than all of the other faces. So if you notice in this picture here, I have 3 rectangles and I have 2 triangles. Those 2 triangles represent the 2 bases that are different than all of the other rectangles. So if those are my 2 triangular bases, then I call this a triangular prism. Okay, and then lastly, this last net is definitely a polyhedra. It does not have any curves. In terms of deciding whether or not it's a prism or a pyramid, all of the smaller shapes within it are the same. They're all squares. So hopefully you could just use your logic here. You know, when you fold this up, it's going to be a cube. Could you technically call it a square prism? Yes, absolutely. But most specifically, we just use the term cube. Okay, so those are nets. The last thing to talk about is a cross section. A cross section. The cross section of a solid figure is the intersection of that figure and a plane. The intersection of that figure and a plane. Cross sections are two-dimensional. Okay, two-dimensional. So it's a two-dimensional intersection of a 3D figure. So you could think about a couple of different things. You could think about, my favorite thing to think about is Food Ninja, that game that used to be really, really popular, where you swipe all of the fruit in different angles, get as many as you can, right? Anytime you slice those fruit, I want you to imagine if we took an orange and we sliced that orange right through the middle, and then you turn that orange to you and you look at the inside of it. The shape that you created with the knife would be a circle, right? A circle is the two-dimensional shape that you cut from the 3D shape. Okay, so that's what cross sections are. So if I look at this example here, let's first of all name this shape. This is made up of all polygons. There's no curves. So this either has to be a prism or it has to be a pyramid. Well, a pyramid has to all end up at one point. This one does not have one common vertex. So this one has to be a prism. Specifically, the 2 faces that are different than all of the others are the triangles. So this one's going to be called a triangular prism. So you could slice this in many different ways, but the example of the way that they're showing us is if we slice it with a knife horizontal to the bottom. So if this was the cross section of where our knife would cut that prism, that shape, because it is parallel with the bottom of the base, would be a rectangle. Now, I know right now it looks like a parallelogram technically, but you got to remember that the shape is just kind of tilted sideways to show that it's three-dimensional, even though it's a two-dimensional drawing. Okay, but that would actually be a rectangle. So these three examples, I want you to determine the shape of each cross-section. So our first one, we have a cylinder. If I take a cylinder and I slice it with this horizontal plane, I would end up with, this is where the knife would cut, and it would be in the shape of a circle. Right, the next one, this is a prism here, right? It's made up of all polygons, and it's not a pyramid, so it's got to be a prism. And if this is the cross section here, this shaded part in the middle, then that's kind of a dead giveaway that that cross section is a triangle. And then for the last one, they don't show us the cross section. They just kind of describe what it should be. They say that we want to create a horizontal cross section. So we want to take a knife and we want to slice it like this. Well, if I slice it that way, it's parallel to my base, and my base has 6 sides. Therefore, this cross section would be a hexagon. And that's that. Nets and cross sections are really, really, really basic. I've got a short video that kind of shows some animations of cross sections that you'll watch. It's only a couple minutes long, right after this. Then you will go ahead and work on the assignment on the back side of this, and it says practice. And this should be very straightforward for you. Numbers 1 through 4, just matching using this shape over here, figuring out what the vertex, edge, face, and base are. Number 5 and 6 ask you to classify each figure and then name the vertices, edges, and bases. So then you fill these out here. We kind of did a couple of those yesterday on our notes. And then 7, 8, and 9 are nets, which we just did on the notes today. 10 and 11, it says cross section. So that's also what we did today. And then the last 4 are kind of just visualizations of some 3D objects that you should know pretty well.